I want to show you how to run and interpret a Chi Square test using SPSS. So to do that, I'm going to need some data. So let me just share my screen with you and find some data. So this is a cross-sectional study, simply meaning it was taken at one point in time, and it was two variables, beverage, tea or coffee, versus the state as self-reported by the participant, whether they felt chipper, upbeat, or not upbeat, or as they hilariously call it here, no pulse. Now, there were 100 participants altogether. So I need to point out, first of all, that this is a frequency table. It is not raw data. So we have to bear that in mind when we come to open SPSS. Also, you'll notice that both grouping variables, beverage and physical state, are what's known as nominal level data, also known as categorical level data. Now, in quantitative research, variables are coming in what's known as a hierarchy of data types. You have nominal level at the bottom, then ordinal, then interval, then ratio. Nominal is typically a grouping variable. Ordinal is ranking variable like good, better, and best. Interval and ratio are variables that you'd recognize as typical measures like height, weight, blood pressure, degrees, centigrade, that kind of thing. So for us, the variables are only categorical, only nominal, and in fact, the frequency of the count is also considered to be nominal. So why am I saying we therefore will use a chi-square test on this? Well, in a book by Greene and Oliveira back from 1982, and I'll give the reference to this in the description below, it gives us what's known as a decision chart, which allows us to decide as a researcher, as a statistician, which tests we should use. Now, there's lots of tests mentioned here, by no means all of those that are out there, but the common ones. Correlation tests, ANOVA test, t-test, Mann-Whitney. Some of these you'll have heard of before. But at the very top, after it says start, you have to make three considerations. And if your data is only categorical, only nominal, as ours is, then you only have a choice of one test, and that is the chi-squared test. But at least there's a test for us to use. So that gave us permission, as it were, to think about the chi-squared test. Okay. Next step then is to upload SPSS. And like a good Blue Peter viewer, I have prepared it ahead of time. The big difference between SPSS and say Excel is that there's an extra tab, an extra sheet that you have to fill in and should fill in first before you put your values in. So that is where we select the variable view to define our variables. Now we have three variables, two grouping variables, beverage and physical state, and one count variable, the frequency. Okay, I put those in, and I've made them all to be numeric rather than say string, because I wanted to be able to code it. So for beverage, I decided on the code just out of convenience that 1 equals coffee and 2 equals tea, and similarly for the physical state, the mood, 1 for chipper and 2 for not so chipper. Okay, so far so good. The other thing I made sure was that the measures were, in this case, all nominal. You can always change these after the event if you need to. You'll notice that in SPSS, they don't bother to distinguish between interval and ratio. And indeed, some textbooks do this. They just compress the two and call them scale. But we're not worried about that here and now. We're picking nominal. So everything is set up as regards defining my variable. And then I put the data in itself. Now you'll notice this does not look like that table I had. This frequency table, sometimes called a contingency table or a cross tabulation, depending on your textbook, looked fairly straightforward and intuitive here. Those four core values of 5, 10, 70, and 15, that's what's known as my inner 2x2 table. So this is a 2x2 contingency table. But I can see I've got 5 coffee drinkers feel chipper and 10 tea drinkers didn't also felt chipper, whereas in SPSS, the data's all there, but I had to put it in a subtly different way. So 5 coffee drinkers were chipper, 10 tea drinkers were chipper, and so on. We will get one other chance to check that this was correct, because it's quite easy to make a little mistake here. Now, I warned you a moment or two back that because this is raw data, we don't have 100 lines of code, 100 lines of data put in. It's summary, but we know that. SPSS doesn't yet know that. So to let SPSS know that our data, our counts, our frequencies are not actual measures, we select data and go right down to the bottom where it says weight cases. It's almost at the just off your screen there, but if I select that, the default is that we're not weighting any cases by anything, but we know we want to. So we want to weight cases by frequencies. I select the frequency from the left-hand pane and use the arrow to move it over. When I click OK, from here on in, I will SPSS will treat that value counts as a frequency, but only for the duration of this particular SPSS session. Once I come out of SPSS and finish, it'll revert back. So we'd have to make sure we have that turned on or not, depending. But everything is now ready for me to run the chi-square test. And this is the easy bit. We're going to analyze descriptive statistics, and SPSS uses the phrase crosstab, short for cross tabulation, but we know that to mean frequency table or contingency table. So if I select that, off we go. Now, how did I arrange it with my PowerPoint? I had physical state with my rows. So let me go back to this. So physical state, I'm going to put into the rows, and beverage type, I'm going to put into the columns. I don't need to select the frequency, the count, because SPSS already knows that that is a weighted number. It is my proportions, as it were. So I then need to tell SPSS which test I want to run. Now there's lots of options here, but I only select two. The obvious one is top left, chi-squared. I definitely want to run that test. And if I'm lucky and I get a p-value of 0.05 or less, we know that that means that the results are statistically significant, and that therefore any association between beverage and how we feel will be not due to chance, and will therefore likely want to say something about the strength of that association. And therefore we tick phi and Kramer's V. It'll give us two outputs, two measures of importance of relative value, and that'll be the phi value and the Kramer's V, but more about that in a moment. So they're the only two things I click continue, click OK, and then SPSS produces a table of outcome with 4 tables. The only one we really want to focus on is the third one down, but I will quickly look at the others. The first table reassures me that I did do my job correctly. I ensured that SPSS knew that counts was a frequency. So that tells me that it thinks and it knows that I have 100 values it's considered good. The second table is SPSS now arranging the contingency table, what is called a cross tabulation, in a form that I recognize, and I would definitely check this with my original data. And if I look at my original data, yep, it's all the same. So I'm happy with that. And now the results of my chi-squared test. Now, this is where it can get very confusing, because we did expect to see a result of a chi-squared test, but it's giving me lots of lines here. Now, the chi-squared test is also known as the Pearson chi-squared test, and it's given me a couple of values which I'm not sure what they mean. Something called the chi-squared value, the test statistic of 16.340, and something called DF, which stands for degrees of freedom. Not going to worry about that here, because what we focus on to begin with is the p-value. Now, SPSS refers to the p-value as the asymptotic significance. Okay, fine, I'm happy with that, but I am quite reassured, at least momentarily, that that clearly is a value less than 0.05. In fact, it's a lot less than 0.05. So on the face of it, I could say there's strong statistical significance, or rather, there is strong evidence against a null hypothesis. But hold the front page. There's a little note here, A, and if I read A, it tells us that one of our 4 cells, remember this was a 2x2 table, this 5, 10, 17, 15, one of those values, i.e. representing 25% of my entire table, has an expected count less than 5. And that furthermore, the minimum expected count in one of those values is 3.75. Should I worry about this? Well, yes, I should. Let me just stop sharing for a moment and let's get to the bottom of this. So there's a very useful textbook by Reid and Boore called Research Methods and Statistics in Healthcare. And again, I will put this in the description below. But on page 94, they talk about the uses and, importantly, the limitations of the chi-squared test. Now, for any chi-squared test bigger than 2x2, the 2 limitations are that any cell must not have an expected frequency of less than 1. Well, we didn't come across that, so we're fine. But also, more than 20% of the cells must not have an expected frequency of less than 5. Now, that did occur here, but ours isn't a bigger than 2 by 2. It is a 2 by 2. It then goes on to say on page 25 that there's a special case, the 2 by 2 chi-square test, which is what we've got. And it says the 2 by 2 contingency table can only be used if the grand total is at least 20. Well, that's all right. Our grand total is 100. Fine, we've passed the first test. But the second one says there should be no expected frequency out of those 4 values of less than 5. But we know one of those were less than 5. But we've got a get out of jail card. It says here, if either of these conditions are not met, an alternative test should be used instead, which is the Fisher's exact test. So back to sharing my screen with you. Let's go back to our output. All that has told us is that because we have a 2 by 2 test, and because we had a count of more than 20% less than 5 of the cells rather, it means that we don't read this top line, we drop down to this 4th line, which reports the outcome of the Fisher's exact test. So phew, that's fine, but it was important to have that discussion, because if you're writing this up in a report and you dwelt on the Pearson chi-square and just went ahead, even though your p-value just happened to be the same as it is for the Fisher's exact, you've run the wrong test, you've reported the wrong test, and it would kind of, you know, drop you serious marks. But we got out of that back when we anticipated it. We're going to read the output of the Fisher's exact. There are no test statistics to report, but that's okay. I don't mind. I'm homing in on my p-value. It's actually given me 2 p-values, one for a 2-sided test and one for a 1-sided test. Now, unless you know what you're doing, you generally pick the 2-sided test, which we're going to do here. So on this occasion, it wouldn't have mattered, but I can report that there is a strong evidence against the null hypothesis, i.e. that we have achieved statistical significance. And because we've achieved statistical significance and we've shown in all likelihood that our results were not due to chance alone, we can now ask one final question, which is, are our results clinically significant? In other words, what is the size, the effect size of this association? And this is where that Phi and Kramer's V came in. Now, just to remind myself which one I pick out. Now, it turns out that if you have a contingency table, a cross-tab table greater than 2 by 2, you use Kramer's V. And if you only have a 2 by 2, you use the Phi. Now, I know that values are almost the same, but it's the Phi value that we use. And this has come from Gravetter and Wallnau 2004, and I'll give that also in the description below. So to report our effect size, we know it's minus 0.404. And the p-value is less than 0.05, which is good. We can ignore that minus sign. We're just looking at what's known as the magnitude, the size of that number, 0.404. How do I interpret that? Is that small effect size, medium, large? What is it? Well, what Gravetter and Wallnau go on to say is that if your measure of effect size is around 0.01, that's considered small. Ours is bigger than that. If it's around 0.30 is considered medium, and if it's 0.5 and above, it's considered large. Well, this is at the upper end of the medium scale, so I would say that we have a medium effect size. So in reporting this, I would say a Fisher's exact test was carried out, and I would have explained beforehand why I couldn't quite do the Pearson chi-square test. It showed that we have strong evidence against the null hypothesis because the p-value was way less than 0.05, and that therefore we can declare our results to be statistically significant, not due to a fluke. And furthermore, we can say that it has a medium effect size. The effect size, the strength of the effect of this association is medium. And obviously then go away and do some more thinking and writing about what that means in your particular context. But I'm hoping that has been of some help to you. I'm just going to stop sharing my screen now and sort of end it there. So ultimately, I would advise you, if you're not on the chi-square test before, to maybe just mimic it with the values I've given. That's how I learned it. Make sure you know what you're doing, and then you introduce your data. And of course, I've only shown chi-squared for summary data. If you've got the raw data, if I'd had, say, all 100 values there, then you wouldn't pick the data weight by. You would just do it without that selection. See how you get on, and I'm hoping it's of some help. So let me just stop the recording there, and I will see you in the next one. So take care and thank you.